So matrix A is given. First we need to find the determinant of matrix A, and then we need to determine whether matrix B is an inverse of matrix A. So let's start by finding the determinant. We will use the expansion along the first row. The expansion along the first row is used to find the determinant of 3 by 3 matrix. Let's review the formula of this expansion. So basically, if you have a matrix x1, I1, z1, x2, y2, z2, x3, y3, z3. So the determinant of this matrix equals x1, so the first entry of the first row, times the determinant of y2, z2, y3, z3, minus y1, so the second entry of the first row, times the determinant of x2, z2, x3, z3, plus z1, so the third entry of the first row, times x2, the determinant of x2, y2, x3, y3 matrix. Now let's use this formula to find the determinant of matrix A. So the determinant of A equals 1 times the determinant of 0, 3, 1, negative 1 matrix, minus 2 times the determinant of 1, 3, 1, negative 1 matrix, plus negative 1 times the determinant of 1, 0, 1, 1 matrix. Well, now let's calculate this. So the first term is 1 times the determinant of the given 2 by 2 matrix. So it's 1 times 0 times negative 1 minus 3 times 1 minus 2 times 1 times negative 1 minus 3 times 1 plus negative 1 times 1 times 1 minus 1 times 0. So this equals negative 0 minus 3 times 1 is negative 3. Then minus 1 minus 3 times 2 is negative 8. So minus negative 8 is plus 8. And here we have 1 minus 0 times negative 1. So it's minus 1. And it equals 4. So the determinant of matrix A equals 4. Well, now let's move on to the next part. So to verify that the matrix B is an inverse of given matrix A, we will use the definition of identity matrix that states that A times A inversed equals identity matrix. So let's multiply matrix A and matrix B, and if we get identity matrix as a result of this multiplication, that will mean that matrix B is an inverse of matrix A. So matrix A times matrix B, and it equals, so here we get 1 times negative 3/4 plus 2 times 1/4 times 1 minus 1 times 1/4. Next, 1 times 1/4 plus 2 times 0 plus 1 times 1/4. Let me move this a little bit to the left. And next entry is 1 times 6/4 plus 2 times negative 1 minus 1 times negative 1/2. Again, I'll move this a little. 1 times negative 1/2. In the next row, we have 1 times negative 3/4 plus 0 times 1 plus 3 times 1/4. Then 1 times 1/4 plus 0 times 0 plus 3 times 1/4. Then 1 times 6/4 plus 0 times 1 plus 3 times negative 1 over 2. The next row we get 1 times negative 3/4 plus 1 times 1 minus 1 times 1/4. 1 times 1/4 plus 1 times 0 minus 1 times 1/4 and 1 times 6/4 plus 1 times negative 1 minus 1 times minus 1 times negative 1 over 2. And this equals, let's do the calculations. So here we get negative 3/4 plus 2 minus 1/4. 1/4 minus 1/4, 3 over 2 minus 2 plus 1 over 2. Negative 3/4 plus 3/4. 1/4 plus 3/4. 3 over 2 minus 2 over 2. Then we get negative 3/4 plus 1 minus 1/4. 1/4 minus 1/4. 3 over 2 minus 1 minus 1 over 2. So here we get 1 0 1 0 0 0 1 0 0 0 1 0 0 1. Great. So as you can see, we have received an identity matrix. So that means that the given matrix is inverse of matrix A. So it's B is the inverse of A.